Hello friends, in this video we will talk about this topic. Yes, this topic, binary tree traversal. We will look from a very basic things, what is binary tree, what are the different types of traversal, and we will see the recursive code of that as well. So stay tuned. Let's see what is binary tree and then we will talk about its traversals. What is this? You may say empty, but I will say it is a binary tree. Null is a binary tree. Okay, and if I wrote a node, a single node, it is a binary tree. Yes, it is binary tree. Now you might be wondering what kind of definition I am giving. I am trying to explain you from the very basic things so that you will understand what are the different binary trees that we have. Null is a binary tree, a single node is a binary tree. So any tree which has only one node, at max two nodes, that is called binary tree. It can have one node, it can have two, but it cannot have more than two. Even it can have zero child, right? Then that is also a binary tree. So this is binary tree, this is also binary tree, this is also a binary tree, but this is not a binary tree. This one exists, right? So I hope you got the idea what is binary tree. These kind of trees we have given a name called n-array tree. We will talk on that on some other day, but today let's look at binary tree traversal and why these traversal are needed. These traversals are needed so that we can represent a tree in a serialized form. Okay, so let's see. There are three types of traversal in binary tree. First is called preorder traversal. Second is called inorder traversal. And third is called postorder. So let's see what is preorder, what is inorder, what is postorder. If I create a tree and giving some name 1, 2, 3, 4, 5, 6, 7. By the way, this type of tree is also called something. Can you guess? It's called complete tree because complete tree is a tree where every node either has two children or no children. So in this 1, 2, 3 has two children, 3, 4, 5, 6, 7. These have 0 children, right? So we have given a name to such tree as complete tree. Now let's see the definition and how the traversal occur. In the preorder traversal, first we have to basically write about the node, root node, and then visit the left child and then the right child. So in this case, when you visit this, let's say we are printing, right? So if I want to print the preorder traversal, I will visit first this, right? Print 1. Then I have to print 2. Okay. And then before moving this to 3, we have to print this whole tree, right? This subtree. So we have printed 2, then number of 4 will come. We have written 4. Now it's left child which is null, so it's not needed. Again right child is also null, so 4 is done. So this subtree is done. Now the number of this particular term came, right? So we will write 5. After this 5 is done, then this whole subtree is done. We will move to this particular subtree. So here we have 3, right? Then 6 and then 7. You guessed it, right? Yeah. So now move to in-order traversal. Let's see one by one these so that we can compare. In the in-order traversal, what happens? We have to first see or visit basically the left child and then the root and the right child. So in this case, what is the left child? Before writing 1, we have to write this 2, but before writing 2, we have to write 4 because of this subtree. So here the 4 will come first, and then we have to visit the root. Its left child and right child is none, so not an issue. Then we will visit 2. After that 5, because root is visited, then the right child. After this subtree is done, right? Now the number of 1 come, so 1 will be written. And then can you guess on this? Pause this video and try to guess what should be the printing of this subtree. I hope you guessed it right. It will be 6, then 3, the left child, then root, and then the right child, then 7. This is our in-order traversal. Now let's talk about post-order traversal. So in post-order traversal, what happens? First we have to visit left child and then right child and then the node, the root. So let's try to write for this first left child, okay, then this subtree, and for this subtree before writing 2 we have to write 4, so 4 will come. Then the number of root will not this particular right subtree we have to visit first left, then right, and then root, so 5 will come, and then 2, right? So this subtree is done. Before writing 1 we have to visit its right child, right subtree basically, right? So for this, can you guess? Is 6 left, then right, 7, and then 3, right? So this is written, this is left, this is right, and then 1. So similarly, if we try to draw in pre-order traversal, first we have covered this left, then root, and then the right subtree. And in this case, first root, then left, and then right. So if you remember one thing, in pre-order traversal, first root will be visited, then left, and then right. Let me write it. In this, first root, and then left, and then right. Okay, here in order traversal, first left, then root, and then right child, right subtree basically. Similarly, in post order traversal, we have first left, then right, and then root. So I hope you got the idea about these traversals. The questions on tree traversal are most common in almost all the full stack development interview jobs. So this has to be mastered, and not only from programming perspective, you will get a lot of ideas about how the tree can be represented. And in your computer science, almost everything, wherever there is a hierarchy is involved, a tree structure will come. And when the tree structure will come, there is a requirement for serializing that. So the traversal will come. And these are the three traversals that we have seen in this video. So let's see the code of preorder, inorder and postorder. Here I will talk about mostly the pseudocode, so that based on the language, whichever you prefer, whether it is JavaScript or Python or Java, C++, you can replicate that based on the syntax of that particular language. So let's see, on this tree we have to write about basically a preorder traversal. Preorder, right? And it will take its root as an argument. Okay, and this is a pseudocode, so I am not worried about the syntax. Just focus on the steps. Now in preorder traversal, first we have to visit root, right? So let's say there is a function called visit, which will take a node, right, and it will do something with this node, whether it can print node value, right, or it's just, let's take just a argument. Okay, so this can print, or it can do some complex operation, like it can send over the network, or it can write that particular file on the disk, or whatever, right? This visit is like your own logic on that particular application. So here I am taking for simplicity this printing this element, right? So in preorder, what happens? We have to visit first the root. So we will visit this root, right? Now let's say we want to visit our left child. So what we have to do, left subtree, right? So if we call this function recursively, which is basically root dot left child LC, and then once this is done, then preorder root dot right child, right? So these are the steps, but because this is a recursive function, so if there has to be a base condition through which your recursive function will end, right? All the recursive function has this thing. So here what can be the base condition to break this recursion? This recursion can be breaked at if, let's say, your root equal to null. Then just return. Else you perform these operations. Is this making sense? First, our base condition is definitely root equal to null, then just return. First visit the root, second visit the left child, and then the right child. So this is all about in preorder traversal. Let's talk about inorder traversal. So in the inorder traversal, what we will take? We will write first base condition. If root is null, then we can just return, right? If this is not the condition, then what? In the inorder, we have to visit first the left child, then root, and then the right child. So can you guess the steps that we have to write based on this program? You guessed it correctly. First, inorder root dot left child, then visit root, right? And then third step should be root dot right child. So we have visited first left child, then root, and then right child. So with these two examples, can you write the code of post-order traversal? This is up to you, that you have to write it, and paste that your code, your steps in the comment section of this video. It will be helpful for others as well, and it will be helpful for you because when you write it, it stays with you. You will remember for a longer time. So in this video, I hope you got the idea what is binary tree, what are its different type of traversal, and we have seen the code of recursion based code for these traversal. So if you like this video, please share with your friends and click on the like button and subscribe to this channel. I'll create more videos like this on computer science, on different technologies. Please let me know in the comment section on what topic I should create video for you, and if there are any issues that you are bothering, please let me know in the comment section. I will try to resolve those as well. With this note, I'll take a leave. This is BK from Anikka signing off.